So ASA, as we know, it is called as adaptive security appliance. Adaptive security appliance. What is adapted there? Adaptive security appliance. Adaptive security appliance. See, what is the meaning of what the meaning of adaptation means, right? Adaptation. Adaptive. No, adaptation means taking into your family. Adaptation. Someone who are not into family, you are taking them into family. That's what adaptation means. Likewise here, there is a device called ASA which has got adapted, which has adapted too many things in it. ASA is a firewall, but it's not just a firewall. It is also a layer 3 router. It is also a layer 3 switch. Sorry, both layer 2 and layer 3 switch. It is also a box in which you can do virtualization, like as you do in a VM environment. It is also a box where you can do VPN, so kind of VPN concentrator. It is also a box where you can run IPS, intrusion prevention system, on it. So a lot of things are adapted, and it is a single box solution. That's the reason why we call this adaptive security appliance. It has got many features in it: routing, switching, virtualization, firewall, IPS, VPN concentrator, and much more, right? So ASA is single box solution. Now, any firewall, you can categorize into two different categories, as we already saw in the first day of class: stateful or stateless firewall. Now, what sort of firewall is ASA? ASA is by default stateful firewall. Stateful firewall. Now, this stateful firewall by default inspects most of the TCP and UDP traffics. Almost most of the important TCP UDP traffics are inspected. Now, what does it mean? Can someone explain what does it mean when I say it is inspected? Good. It inspects the traffic. It is seeing who is going to whom. Means it is doing what it does. Stateful job. It is doing stateful job. So what I'm saying here is most of the TCP and UDP traffics are by default inspected. That's why when you have an ASA, let me pull an ASA here. Or let me have a topology which I already got. So I got all my license in place. I need not to restart or anything like that. So I already got this topology built. Let me show here. So you will by default see some inspections, some class maps and policy maps. Alright, so I'm going to show you once it booted. It's getting booted. So those class maps and policy maps are doing what? Inspection. Inspecting almost all frequently used important traffics from an organization. so that the return traffic will be allowed from the outside to the inside. That's the idea of statefulness. This point, you need to keep in mind, most of the TCP and UDP traffics are inspected. Next point is, as we did in zone-based firewall, here also you see zones, but not the way that you did in a router. This is slightly different. In router, what we did is we created zones, we applied the interface to the zones. Whereas in ASA, you must name the interface, and that name will become a zone for that interface. So you don't need to separately create a zone by giving a command called zone security. You just go under the interface. Say for example, you have an ASA and you may have many interfaces, but by default none of this interface will be active. Even after saying no shutdown, interface will be down only. Why? It's a firewall. Interface need to be in a zone to become active. It's not a normal router. Normal router, whether you have zone or not, when you say no shutdown, the interface will become active. ASA is not like that. ASA is a firewall. Just by giving no shutdown or giving an IP address will not bring the interface up. Very important fundamentals that you are learning here. So unless you put them in a zone, unless you assign a name to the interface will not become active. Okay, let me go back to the CLI. Okay, here is the CLI, and you see I got my ASA ready, and show version. Let me see the license. Oh, I don't have a license. I'm sorry. All are disabled. I need to put the license quickly. So those inspection statements, inspection, statefulness. By default, it does inspection for these services like Skinny, NetBIOS, TFTP, SIP. Now, for all this FTP protocol, by default, it does inspection. So let me show you in the running configuration, show run. You see, this will be there by default, and it is binded globally. Globally means, for all interface, this inspection is applicable. And this is by default. You need not to tune anything. It is there by default on every ASA. Now, my ASA is as equal to my real ASA. So let me restart because I put the license now. Let me restart it. So now we got our ASA ready and we got the license there. Next, what is next? Next, let's get into the fundamentals that we were learning. As I was telling you, unless you put the interface in zones, the interface is not going to come up. The interface will not be supporting any protocol. So you need to put them in a zone. How do you put them in a zone? You don't create any zone as you did in zone-based firewall. You will just assign a name to the interface, and that will bring the interface up. So naming the interface is very important. Now, in that, if you will name an interface with this name, if you will name an interface with any of this, all lowercase, all uppercase, mixed case, if you will name any of the interface with any of this name, that interface is the highly trusted interface. The word inside is a very powerful word on ASA. That interface is highly trusted interface. All traffics are allowed there. No block. It's highly trusted. Highly trusted interface. Okay. Highly trusted interface is inside. Now, how do you measure the trust relationship? With a numerical value. Trust relationship will be between 0 to 100. 100 most trusted. So the moment you say you give this name inside in any manner, you get the security level 100 assigned by itself. You need not to assign it. It by default assigns the trust level. It is also called as security level. The security level is 100 by default for the interface that has got name inside on it. Highly trusted interface. Any other name you give, the security level will be 0. So any other name, security level will be 0. Means, not at all supported. No traffics are allowed. That is how ASA by default behaves. Any name. I give this interface a name called outside. So what is the security level by default? It will get 0. I give this interface a name called DMZ, demilitarized zone. What is the security level? It will get 0. Now, can you change the security level? Yes, you can change it. If you want to make it as 50, you can make it as 50. But by default, anything other than inside, it is 0. You can change the security level. You can. Now, why should someone change the security level? What is the advantage in changing the security level? Traffic from higher security level to lower security level is permitted. Traffic from high to low is permitted. What I'm coming to say is, if DMZ is 50 and outside is 0, traffic from DMZ can go to outside. Similarly, traffic from inside can go to DMZ. It can also go to outside. But traffic from outside cannot come to neither DMZ nor inside. Traffic from DMZ cannot come to inside. Why? In DMZ it is 50. Inside is 100. So traffic from high to low is permitted. It is like a river. River water flows from top of the hill to the down the valley, but it won't go back valley to the mountain. Not possible unless someone pumps it with a motor. If someone pumps it from valley to the mountain, yeah, it is possible. Likewise, if you want traffic from outside to come in, you need to pump it. You need to allow it by writing an ACL or by doing NATing or by inspecting. Only then it is possible. So let me repeat. Zones are mandatory, must in ASA. How do you create zones? By assigning an interface a name. By assigning a name to an interface, it creates zones. Once it creates zones, it will not use the interface names. It will use only the zone names. I'll show you an example when I demonstrate with the device. So G0 will not be seen at all. When you assign a name called outside, that interface will not be called as G0. It will be called as outside only. In the routing table also it will see outside only. It will not say G0 interface. It will not say G1 interface. It will say inside interface. So when you assign a name to an interface, that becomes a zone plus that also becomes the name for the interface, and the interface actual name like gig ethernet or fast ethernet will not be in use. Only the zone name you should use wherever you want to call the interface. And when you assign a name called inside with any case, uppercase, lowercase or mixed case, you get the highest security level called 100. Any other name is 0. Traffic from higher security level will flow to the low security level. But low to high is not possible by default unless you inspect it or write an ACL to permit it or NAT it from outside address to inside address. Unless you do these things, not possible. Traffic from low to high is not possible. Now let's do some basic configuration on ASA. To do that, let's see the topology. Okay, according to this topology, I need to assign this IP address to this interface, this IP address to this interface. Just forget about these two interfaces, G2, G3. Don't concentrate now. Our focus is only on G0 and G1. We want to assign an IP address to this interface. Same like a router. You say config T. Yeah, I'll show you those commands. I'll show you the command differences. There is slight difference. 80% same. Okay, so now yeah, I'm going to show you. Now you see I have come to the global mode. Now here what you need to do is, let's see the name of the interface. Show interface IP brief. Command is not show IP interface brief, slightly different. You put the IP next to interface. Yeah, any mode. That's the good news. Show command will work in any mode, user friendly. It is not like a router. In router you need to go to privilege mode every time, or you need to use do command. In here you're lucky, you can do it anywhere, on the physical interface, in the global mode, under the routed mode, any mode. Okay, now I can see that the interface are administratively down, and it has got G0, G1. So let me go to G1 first, interface G1. I'll say no shutdown. I'll give IP address 172.16.0.10. Now, what is the default mask for this 172 network? Wonderful. It is class B/16. And if it is default, you need not to mention it. If it is router, it will say incomplete command. We must mention the subnet mask even if we have not done any subnetting. But ASA understands, okay, he has not provided me the subnet mask, so let me provide /16. So it will provide by default. Now I want to show you that. Okay, in any mode you can try that. Show run interface G1. You see, you didn't give this mask. It automatically gives. Now one more command. Wait. Show interface IP brief. This is the command to see the status of the interface, correct? Look at this. It is up only, but where is the IP address? I am seeing the IP address on the interface, but here the IP address is not shown under the status. What it means is, it means that I am not ready to do any service. I don't need an IP address. Why I am not ready to do? Because no zone is assigned. You see, there is no name given to this interface. Unless you provide a name, I am not belong to any zone. If I am not belong to any zone, I am not going to do any service. So let's give a name. Name if, and I am giving inside. It can be any case. I am saying INS IDE. Now I am mixing the case. Even if you mix it, it is going to give by default high trusted security level. Highly trusted security level 100. Now, if you want to change this also, you can change it. If there is really a need to change it, you change it. I don't think there will be a need. Now, next is, let me check it now. Show interface IP brief. Look, now the IP address is coming up. Okay. What is the interface on which I gave this IP address? On G1. Show route. No show IP route. Simply show route. To see the routing table, show route. Look at this. It is not saying, it is not showing you G1. Usually in routers, in the routing table, we will see G1. But this time, in firewall, you don't see interface. Instead, you see the zone name. That is how it is. So whenever you bind an access list, you will not bind it to G1. You will bind it to inside or outside. Only to the name, zone name. It's same like applying the service policy on the zone pair, as you did in the zone-based firewall. Okay, so we got inside here configured. Let us also give a host name ASA. Right, let me bring this router 1 and try pinging the ASA's inside interface. Do show IP interface brief. No IP address is assigned. Let me assign interface F1/1. No shut. IP address 172.16.0.1. 255.255.0.0. Alright, what I'm expecting is a ping between ASA and this router. So I'm pinging the inside interface of ASA. Ping 172.16.0.10. It will ping. Yeah, it pings. So we have direct adjacency connection between R1 and ASA. Let us finish the configuration on the other side of ASA. Interface G0. No shut. IP address 20.0.0.1. Default mask, so I am not mentioning it. Name if. See, anything you type other than inside, security level is going to be 0. So I am going to say outside. You see, the security level is, the security level is 0 by default. If you want to change it, you can change it. Let me show you how to change it. Now, whenever you give a name to the interface, it will take some time because it is creating actually zone behind the screen. Not always, it depends on the processor availability. Okay, now security level. See, if you want to change the security level, this is the command. Security level, I'm giving 50. So I'm changing from 0 to 50. What is the verification command? The best verification command for security level is this. Show name if. When you type show name if, it will show you so nicely which interface, what name and what security level. Very nice troubleshooting command. Alright, when I am not seeing my IP address on show interface IP brief, which means I have not given name. How do you verify that? You can go to show run and check, but best command is this, show name if. It will show you whether you have given name or not. When you give a name, then it comes on the interface. Now let us check the routing table. Show route command. You see, I got inside, I got as well as outside. Let me bring the outside router R2. Let's assign IP address on R2. Interface F0/0. No share. IP address 20.0.0.2. 255.0.0.0. I am expecting a ping between R2 and R3, R2 and ASA. So let me ping 20.0.0.1. Then I'm pinging the directly connected. I'm pinging the directly connected interface. I'm pinging from R2 to interface of ASA. My traffic is not passing through ASA, sir. You understand? Passing through is different. Pinging that device is different, no? Pinging that device is not really stopped by ASA. What is stopped? Passing through is not allowed. Why? It is going from low to high. If it is going from R1 to R2 to R1, then what you are saying is correct. It will not allow. Let us try pinging 172.16.0.10. See, this ping is not happening. Even though it is on the router, even though this 172.16.0.10 is on the firewall, it is not allowing. Why, you know? It is trying to pass from zone outside to zone inside. Zone outside is lower security level 50. Zone outside is lower security level 50. Zone inside is higher security level 100. See, it's not pinging. It will not ping. Alright, so pinging the directly connected interface will happen because it's not passing through the firewall, it is just touching the firewall and coming back. Alright, similarly, if we go to R1 and ping the directly connected, it will ping as we already tested. And when we try to ping 20.0.0.1, the ping is not happening. Why, you know? Traffic from high to low will go, no doubt. But the reply has to come from low to high, no? The reply is not coming. Low to high reply is not coming. That's why you are not able to ping. It has to pass through the firewall and come from low to high, 50 to 100. That's the reason why ping is not happening. So you need to permit. Unless you permit it, it won't be allowing. One more thing. I'll go to R1 and write a route to reach or enable a routing protocol like OSPF. I'll enable OSPF on R1 and ASA1 and then on R2. I'm going to run OSPF on all the three devices. OSPF. So let me start from ASA. Very easy. If you know how to enable OSPF in a router, it's the same way with slight different. How? Router OSPF process ID network 172.16.0.10, and then we need to type a mask. So yeah, router 2 configuration is same as router 1. You see, I gave an IP address on router 2 and I was pinging the ASA's interface and it is pinging. Now I'm enabling OSPF on all these three devices, R1, ASA1 and R2, so that we can have reachability from inside to outside. Alright, I'm starting from ASA. On ASA, I'm saying router OSPF 1, network 172.0.0.0, and then what? Someone tell me. And then what? Sorry? That's all? Come on, you are in OSPF. No, before that. How do we enable OSPF on a router? We say network and then the network followed by wildcard mask, correct? Wildcard mask. But in ASA, you no need to write wildcard mask, you will write only subnet mask. So it will be 255.255.0.0. Please remember, on ASA, no wildcard mask anywhere, only subnet mask. On the router, it is subnet mask. Sorry, on the router it is wildcard mask. On the ASA, it is only the subnet mask, followed by area ID. Similarly, network 20.0.0.0, 255.0.0.0, area 0. Now OSPF is enabled. On ASA, I have OSPF. What is the verification command? Let's check some verification command. Show OSPF. You see, OSPF is running, and this is the router ID it has taken, and this is the domain ID. It takes automatically. You don't need to worry about domain ID. And number of interface in this area is 0. And what is the area? Backbone area. We have only area 0. But it is an inactive state. The reason is we don't have any other router configured. So let us go to R1 and configure OSPF. A router you can configure anywhere. You can configure OSPF under the interface, or you can configure under the global mode. Let me do it on global mode. Router OSPF 1, network 172.16.0.0. Someone tell me what is next. Yes, it is not subnet mask, it is wildcard mask. Area 0. Only on ASA you have to write subnet mask. Okay, look at this. Yes. Now router and ASA has formed a neighbor. Let us check it out. On R1, let me check. Show IP OSPF neighbor. It shows our ASA's address as the neighbor. Let me also check it on ASA. Show OSPF neighbor. No IP. Don't put show IP OSPF. In router you put what? Show IP OSPF. In ASA, don't put IP. It shows router 1 as a neighbor. On which interface? On inside interface. It is not showing G1 interface. Whereas on the router, it will show the interface name itself. F1/1. Whereas on ASA, it is zone name. Next, let's do it on R2. Router OSPF 1, network 20.0.0.0, 0.255.255.255, area 0. So I'm expecting another neighbor. Okay, I got a neighbor. Let's check it out now. Show IP OSPF neighbor. We got the neighborship. Let's check it on ASA. Show IP OSPF neighbor. Sorry, show OSPF neighbor. I got two neighbor. One is on the inside interface, the other one is on the outside. Now, If I go and check in the routing table of R1, show IP route, I'm seeing 20 through OSPF. See, this is not blocked. I was telling you by default, most of the TCP UDP traffics are inspected. So this type of management services are by default allowed, inspected. So even though it is coming from low security level, this is not getting stopped. See, on zone-based firewall, if you want this to happen, what you need to do? No. On CBAC you need to put access list. In zone-based firewall also, OSPF you didn't really allow it yesterday. It was working. So anywhere zone comes into picture, the management traffics are taken care. OSPF is a management traffic here. It's taken care. Alright. Now you got the route to reach R2. But if you try pinging R2's address 20.0.0.2, the ping will not happen. Why? By default, traffic from low security level to high security level is not allowed. But that is not the case for TCP and UDP. What I'm coming to say is, if I telnet R2, let me first of all enable telnet. Line VTY 0 to 4, password 123. Now if I go to R1 and telnet 20.0.0.2, it will happen. You see? Ping is not happening, but telnet is happening. Why? TCP is inspected. You want to check it? I'll go to, not ICMP, correct. I want to show you that statefulness. Show connection. It says that if a traffic is coming from outside interface 20.0.0.2 with the port number 23, only then you allow it to the inside interface. But what is the IP address on the inside interface? It should be this and port number should be this. So the return traffic, it is allowing explicitly. It is reflected automatically. Statefulness is there. You know, so this is not the ACL you wrote, but this is written dynamically for you based on the inspection from higher security level to lower security level. But low to high it will not happen. See, let me enable on R1 line VTY 04, password 123. Same telnet if I do from low security level, it will not happen. Telnet 172.16.0.1, it's not going to happen. ASA will not allow unless you explicitly write an access list or do some natting. Otherwise it's not possible. But from inside it is possible. So on ASA, even though you have a connection now, it's a new connection now, 3 seconds before, this is the old one. Even though on ASA it is saying allow this guy to this guy, but the port number is not matching. When you telnet from R2, it's not happening. Why? You know, on R2 it's a port number is going to be a random port number, but it says if port number is 23, only then I'll allow. But when traffic originates from R2, it will not be 23 at all. It will be a unreserved random number. So this is not going to get matched. So even though you have a session, it's not going to allow traffic from outside to inside. It's highly secure. Only from inside to outside it is possible. So R2 cannot telnet to R1, but R1 can telnet to R2. It is like R1 is like a service provider who can control the customer, R2. But R2, the customer, cannot control the service provider. Okay. So for TCP, and UDP, because the inspection is there by default, you are able to achieve this. You are able to tell it only from high to low, not from low to high. And the return traffic is permitted because by default for TCP and UDP, inspection is there. Now, when you ping, the ping is not going to happen. If you want this ping to happen, is there any way? Yes, there is a way. There are multiple ways. One, as Mr. Sindha said, you need to write an access list. Another one, you can inspect. You can inspect ICMP. By default, ICMP is not inspected. What I'm going to do is, I'm going to inspect. Instead of writing an access list, I'm going to inspect. Show run. You see, when you type show run, these are the things by default inspected. I need to add one more word here, inspect ICMP. So what I'll do is, I'm not going to create any class map or policy map. I'll go under this class map and policy map, which is already inspecting most of the traffics. I'll simply go and get inside that and say inspect ICMP. One small command, you see how much difference it makes. Now if I go to R1 and ping, the ping happens. Because we said inspect also the ICMP. Go to R2 and try pinging. Never happens. Why? Low to high, traffic will not be happen. Even though you say inspect, inspect is only for high to low. If traffic is going from high to low, then I will do inspection and allow the return traffic from low to high. So firewall does its job so nicely. But when you write an ACL, even from traffic from low to high will go if you are not writing the ACL in a proper manner. So anyway, we will talk about ACL later. Now here we have learned the default behavior of a firewall. Firewall by default will not allow any traffic from low security level to high security level to come unless there is an inspection happens when high to low traffic is going. To allow any traffic, you need to do inspection. And we saw an example for telnet. We didn't add any inspection. The telnet was happening. The reason is by default TCP UDP are inspected. But for ICMP, the ping, it was not happening. The reason is there is no inspection for ICMP. But when you add ICMP under the inspection list, under the default class map and policy map, which is binded globally on ASA, it started allowing me to ping from higher security level to lower security level. The ping is happening. Will I be able to see connection here? Show connection. Let me try pinging for repeat for 100 times. Yeah. While the ping is going on, you can see. Once the ping is over, this will vanish. Still ping is going on. Gone. You see? It is gone, which means ping is over. Alright. So the session is maintained till the traffic from high to low goes. Once it is over, then the return traffic will not be allowed. The session will be removed since the traffic is not originating from inside. Any questions up to